Okay, so introduction to SOH CAH TOA and how to find reference angles today. So right over into this packet. Excuse me. First thing we need to do is put your calculator into degree mode. So on your calculator, and this is really critical or else you're going to get every single answer wrong. So you want to hit the mode key. And where it says radian, you need to change it into degrees instead. If you borrow a calculator from the back of the room, you're going to want to check for this every single time that you take it off the docking station, because it has a tendency to reset back to radians. Okay, so just a subtle warning on those. So degree mode for everything trig related, and then you can just click back to your home screen so you're good. If it's your own personal calculator, you don't have to worry. It's not going to change on you. Okay, so SOH CAH TOA. So sine is equal to your opposite side over your hypotenuse. So sine is just simply your opposite over hypotenuse. We're going to go opposite divided by hypotenuse. You can abbreviate anything you'd like. And then your cosine function is your adjacent over your hypotenuse. And then tangent is your opposite over your adjacent. So opposite over adjacent. In case you forgot from years past, your hypotenuse is always your largest side, and it is always directly across from the right angle. So in this case right here, here's my right angle that you can draw in. And the 13 is going to always represent my hypotenuse. So I want to take this first triangle and label it so that everyone has the same vertices. So let's do this. So over here, let's go A. And your vertices are always going to be capital letters. Up here, let's go B. And your right angle, let's go C. But everyone's the same here. So your first couple are just finding the ratio. You don't have to actually type these in the calculator. So it asks you to find the sine of angle B. So what I'm going to do is start right up at angle B. And my ratio for sine is always opposite over hypotenuse. Okay. So the side opposite B is always going to be the one that is the furthest away from it that you could draw an arrow to. So that's going to be the 12. And then my hypotenuse would be which one? 13. Yep. So I'm going to just leave this. It's just 12 over 13. So this section, these are all going to be expressed as just simply ratios. You don't need to do any calculation work in the calculator. Now I go over and do cosine of B. So here's B. And I'm going to do adjacent over hypotenuse. And because I already know that this one's my hypotenuse, the adjacent has to be the 5 right here. I'm going to go adjacent over hypotenuse if you want to write it. And that is going to be equal to 5 over 13. Next, I'm going to do tangent of B. So again, right back up here is your reference point. You're going to go opposite over adjacent. So we're going to go 12 over 5. So opposite over adjacent equal to 12 over 5. Okay. Does everyone remember doing those in the past? Mm-hmm. Yep, Ashton, correct. Now we're going to change your point of reference. Of course. So we're going to change your point of reference to angle A instead. And yes, this does impact your answers. The only side that's not going to change is your hypotenuse is still here. So now if I do sine of A, I'm going to go opposite, which is now 5, and then over hypotenuse, which is 13. So this ratio changes to 5 over 13. Now I go to the next one. Again, this is my point of reference this time. I'm going to go adjacent over hypotenuse. Remember, the 13 is my hypotenuse, which means 12 has to be your adjacent. So 12 over 13. And then last, you have tangent of A, so you're back here again, and you're going to go opposite, so far away from it. And then adjacent is 12. So I have 5 over 12. Okay, are there any questions on that part? Okay, that definitely should have been content you've seen back in geometry. But if you haven't, don't hesitate to ask, just because we build on those concepts. Now what changes with number 2 is it says actually find it. So this means you are going to type in the calculator. You want to first determine which trig function you have to use. So I'm going to start at my point of reference 48. And I'm going to label on here what I have. This is your packet from last week. So I have here my 48, my 25 represents the hypotenuse, and the x that's across from it represents the opposite side. So what you do now is you look up at your SOH CAH TOA and figure out which trig function uses opposite and hypotenuse. So opposite and hypotenuse is going to be a sine function. So sine is equal to O over H, and then you substitute in. So I do the sine of 48 degrees is equal to x divided by 25. And now I'm going to simply cross multiply and use the calculator to get this answer. So the 25 is a side length and the 48 is an angle. They are different. So when you go to cross multiply this, we place the 25 in the front, then the sine of 48, and your calculator, most of them will open a parenthesis and just close it like that. You're going to type that right in your calculator, and we're going to get an answer to the nearest tenth is fine. So you have 25 sine of 48. So literally 25 sine 48, close parenthesis, enter, 18.6. So we've got 18.6 on that one. And that's it. So that's how you're going to do the rest of these. You're going to identify your trig function, and then you're going to just simply type that in the calculator and round it off. So my next one, find x to the nearest degree. I'm going to figure out what I have here. So this is my point of reference. This is my 90-degree angle, which means this is my hypotenuse, which is not going to get used because we don't have it. So the 509 is far from it. So that's my opposite side. And then the 126 is going to be my adjacent side. So then you go and you look up at the top, which trig function uses opposite and adjacent. So this one is going to be tangent. So tan is equal to O over A, and then substitute in. So we're going to go tangent of x is equal to 509 over 126. What makes this question a little bit different is your angle is unknown. Anytime your angle is unknown, you're going to hit second tangent. So your angle is unknown. So in the calculator, we're going to hit second tangent, which is an inverse tan function. All right, so let me show you where to find that just in case, again, you don't remember from years past. So you're going to go second tan of 509 over, I forgot what it was. 126, thank you so much. Divided by 126. Close your parenthesis and then enter. Basically, you're going to know if you've done it wrong because your answer is not going to make sense. It's going to be a really teeny little decimal. So second tangent, 509 over 126, so 76.1. Okay, so second tan, anytime your angle is missing. So I have 76.1. 76.1 degrees on that one. Okay, so my next one, number 4. I have x is my point of reference. This is my 90-degree angle. Therefore, in this case, your 42.9 represents your hypotenuse. And then the 12.8 is across from it. And anytime you can draw an arrow, that represents your opposite side. So we have O and H. So you're going to look back up at SOH CAH TOA, and O and H is a sine function. So O over H. Again, I do not know the angle. So sine of X is going to be equal to 12.8 divided by 42.9. And what key do we have to hit again? The second. Good. So you're going to type second sine of 12.8 over 42.9. So second sine of that. Again, anytime that angles are known. So we're going to go second sine of 12.8 divided by 42.9 is equal to an answer. I got 17.4. And then next number 5 here. So find X to the nearest tenth again. So once again, you have an unknown angle, meaning we have to hit the second function again. So the 138 is my hypotenuse and the 78 is my adjacent side. So this time you have a cosine function. So cosine is equal to A over H. So I'm going to go cosine of X is equal to 78 over 138. And again, right in your calculator, you're going to type in second cosine of 78 over 138. Okay, so second cos of 78 over 138 is equal to 55.6. Are there questions so far on any of those review ones? You guys remember doing those? Okay. And it's hard too, because some of the topics that usually students are really solid with, because last year was so strange, you know, you might not have mastered those, which is okay. Just if you have questions, make sure you ask, because we build on all of these skills. So number 7, this is what we refer to as a special 45, 45, 90 triangle. Again, you may have seen this last year. This is a triangle you have to memorize. All right, so this is what we refer to as a 45, 45, 90. You have to memorize these values because they're going to contain radicals, and trig equations have to be solved using exact value. So when we get into some of these, you're going to have a lot of answers that are just left as radicals. So here's how this works. Here's my 90. And this is an isosceles triangle, which means that I have 2 congruent sides. So this is 1 and this is 1. Hypotenuse is always radical 2. Okay. So the sine of 45 degrees will always be this value. So sine, you're going to go opposite over hypotenuse. So I go 1 over radical 2. In trig, we do not leave a radical in the denominator. So what you do is rationalize the top and bottom by multiplying by radical 2 over radical 2. And what we use instead is radical 2 over 2. Again, after break, that is something that you do have the responsibility to memorize, but don't do it now because you'll forget it over break. Cosine of 45 degrees, same idea. We start here, adjacent over hypotenuse is the same exact thing. So this is also going to be radical 2 over 2. Next, the 45-degree angle, doesn't matter which one you go off of here. You're going to go opposite over adjacent. So 1 over 1 is just plain 1. Okay. So then your first triangle, again, eventually you'll have to memorize those 3 values. And then we have one more special right triangle. And this is what we refer to as the 30, 60, 90 special right triangle. This is the second and last one that you have to memorize. So go ahead and draw a perpendicular bisector down the middle, which cuts this into 90-degree angles like that. And then what I'm going to do is just branch one of these triangles off just because it tends to help. And label what we have on here. So an equilateral triangle, which is what you started with. Oh, sorry about that. Equilateral triangle is going to have 60-degree angles. So this was my 90. Angle C would have been my 60. And then that leaves me with 30 degrees at the top. Across from the 30 is always a 1. The hypotenuse is always a 2. And across from the 60 is always the square root of 3. Okay, those don't ever change. Then what you do is you take this triangle and you find the sine, cos, and tan of 30 and 60. So the sine of 30 degrees up here is opposite over hypotenuse, so 1/2. Cosine of 30 is adjacent over hypotenuse, so radical 3/2. And again, we do not use decimals for any of these. They have to be left exact like that. Tangent of 30 is going to be your opposite over your adjacent side. So this is 1/radical 3, which unfortunately we don't leave it like that. So you're going to rationalize the top and bottom, and you're going to instead always write this as radical 3/3. So radical 3/3. Now I go to 60. So 60 degrees changing my point of reference. So I'm going to go here now, and I'm going to go opposite over hypotenuse. So this is radical 3/2. Again, that's an exact answer. Cosine of 60 degrees is going to be adjacent over hypotenuse. Now I want to show you a little trick. If you compare these, you see how the sine of 30 went to the cos of 60? And then the cos of 30 went to the sine of 60? So this is always a pattern. So kind of looking at that makes it a little bit easier to memorize, I think, as long as you write them in that order. And then the tangent of 60. So I'm going to go up to 60, and tangent is going to be opposite over adjacent. So this would be radical 3 divided by 1, which is just plain radical 3. Okay. And again, you have to leave those as radicals. You cannot write decimal equivalents for any of those. All right, questions so far? Okay, again, I hope you saw those last year. If you didn't, it's not a huge deal. But those are two triangles we're going to use a lot for all of your trig units. All right, so your next review item here is how angles rotate and where they fall as far as quadrants go. So I'm going to sketch you a diagram with which is what we call your angles in standard position. And then label your quadrants here too. So first, when you label quadrants, you always want to use Roman numerals. So this up here is quadrant 1. Over here is going to be quadrant 2. Below is going to be quadrant 3. And then lastly is going to be quadrant 4. And unless otherwise stated, your angles that are positive are always going to rotate counterclockwise. When we refer to standard position, your triangles that you sketch are going to look like this. So in quadrant 1, you have a triangle that looks like this. And these are always going to be right triangles. In quadrant 2, like this. Quadrant 3 goes down like that. And then quadrant 4 just kind of forms a nice little bow tie shape like that. Okay. That's what we mean by standard position. And your rotation going around this would be like this. So counterclockwise. Next, let's talk about where your angles are. And again, some of you might be really solid on this and remember it from geometry. Others maybe not. So I just want to make sure everyone kind of on the same page moving forward. So quadrant 1 is always going to contain angles from 0 degrees all the way to 90 degrees. Quadrant 2 is always going to contain angles from 90 degrees all the way to 180. Quadrant 3 is going to be 180 degrees all the way to 270. And then lastly, I'm going to be from 270 all the way to 360. And again, these refer to positive angles that are always going to rotate counterclockwise. So just like that. Okay. So we'll find our quadrant placement down here in a second. It's very easy to do. And the next vocab term is what we call a quadrantal angle. And these are angles that lie on your axis. So a quadrantal angle just means, like right here, it defines it. 90 degrees is a quadrantal angle. 0 degrees is a quadrantal angle. 180. And then 270. And then obviously you could continue this, but that's okay. So they are any of those angles that fall right on the quadrant borders. Okay. So your problems down below, all we're going to do is look up at this diagram and determine what quadrant those angles fall in. You don't have to show any work. So 210 degrees is going to be located in which quadrant? Perfect. 315 would be in quadrant 4. 80 degrees would be in quadrant 1. And now a little trick with this last one. It's too big. So you can either do this and then keep going up to quadrant 1 if you'd like, or you can subtract off 360. Either way. So this would just be 50, or you could rotate all the way around and then some. So this places you in quadrant 1. All right, before we do our negative angles, is everyone feeling comfortable? There are a lot of foundational concepts with trig, and as long as you're confident with those, it's not going to be terribly difficult, but you have to have that strong foundation. All right, these angles, so these are still your positives first. So 125 would have fallen which quadrant? 2, perfect. 250 would have been quadrant 3. 520, again, you can rotate all the way around if you'd like, or you could just do this. So 500 is 20. That gives me 160, and 160 places me where? Quadrant 2. 285 places me in quadrant 4. Okay, so that's it. So last, let's discuss where negative angles are going to fall. So I'm going to sketch one more diagram, and then that's it for today, and you can kind of work and make sure you feel okay on these. So negative angles are going to rotate the opposite direction. All right, so we're going to go from basically 0 to negative 90 here. And then the next quadrant, I'm going to go from negative 90 to negative 180. So that's going to be placed there. And then next, I'm going to go from negative 180 to negative 270. And lastly would be from negative 270 all the way to negative 360 degrees. So your rotation is going to look like this instead. So instead of rotating counterclockwise, negative angles are going to go clockwise. So you're going to sketch it like this. when we get to that. Put your quadrants down in here just so it makes your bottom part easier. So here's quadrant 1, here's quadrant 2, here's quadrant 3, and quadrant 4. So name the quadrants that these negative angles lie in. So where is negative 200 degrees? Good, quadrant 2. Again, I don't expect you to show any work for these. Negative 305, quadrant 1. Negative 380, again, you can go all the way and then some if you'd like. So we go around all the way 360 and then 20 more places in quadrant 4. Or if you don't like that approach, you could simply add 360 to this. Either way. And then negative 115 falls in quadrant 3. Okay. Overall, does everyone feel comfortable with those? Okay, good. So the rest of the time will be yours for homework. Again, I don't want to really give you anything this week, so I'm hoping you can finish these now. Tomorrow we'll do a little bit more and then that's it. But don't go memorizing any of these special angles until after break so that you can really make sure you make a valuable use of your time. So you have problem set 1 to do for homework. Those are these problems right here. Your first couple you're just writing as ratios. The other ones you're actually computing. Is there a backside too? Yes, there's a backside too, which is just asking you where your angles terminate. And then that is all. So check those tomorrow. Let me know when I'm coming around if you have any questions or concerns.